Picture this. It is Friday at 4 p.m. The team finishes a sprint. Time to deploy. One engineer SSHs into the server. Runs commands manually. Forgets one step. Production is broken. The whole team stays until 9 p.m. fixing it. This is not bad luck. This is the cost of manual deployment. Here is what most teams do not realize. Manual deployments get slower as the codebase grows. More steps. More things to forget. More risk per release. Azure DevOps Pipelines automates every single step. Code is committed. The pipeline triggers automatically. Tests run. Build is created. Deployment happens. Same process every time. No human error. Full audit trail. By the end of this video, you will know how to set this up. And never do a manual deployment again. Azure Pipelines uses YAML to define your entire CI/CD workflow. The pipeline file lives in your repository. It is code, not a web form. That means it goes through code review, gets versioned, and rolls back with your code. The structure is simple. Stages contain jobs. Jobs contain steps. A step is one action: run a script, build a Docker image, publish an artifact. The trigger section defines when it runs. Push to main. Pipeline runs. Pull request opened. Pipeline runs tests only. Every night at midnight? Scheduled run. And here is the part that surprises most people. Azure Pipelines works with GitHub repositories, not just Azure repos. You do not have to move your code. Connect your GitHub repo and Azure Pipelines handles the rest. The build pipeline runs every time someone pushes code. Here is a typical pipeline for a .NET application. Step 1. Restore NuGet packages. Step 2. Compile the application. Step 3. Run all unit tests. Step 4. Publish the compiled artifact. If any step fails, the pipeline stops. The artifact is not created. Broken code cannot progress to the next stage. But here is the catch that teams miss. The artifact published in step 4 is the exact binary that gets deployed everywhere. Dev, staging, production all get the same compiled output. Not code that gets recompiled on each server. The same binary, promoted through environments. This eliminates an entire class of bugs where code worked in dev but failed in production. Because something compiled differently on the production server. Once your build pipeline creates an artifact, the release pipeline takes over. It promotes that artifact through your environments. First to development, automatic, no approval needed. Then to staging, triggers automatically after dev succeeds. Then to production, waits for manual approval. Here is the powerful part. Each environment injects its own configuration at deploy time. The same artifact uses the dev database connection string in dev. And the production connection string in production. No config file changes. No risk of deploying dev settings to production. And here is what makes approval gates essential. Before production, the pipeline pauses. It sends an email to the designated approver. They check staging, confirm everything looks correct, click approve. Only then does production deployment proceed. This is where most teams get it right. Automated speed where it is safe, human judgment where it matters. This is where most developers get it wrong. They think deployment means, stop the old version, start the new version. That means downtime. Users see errors during the switch. Blue-green deployment eliminates this entirely. You have two identical production environments, blue and green. Blue is currently live. You deploy the new version to green. When green is healthy, you switch the load balancer. Traffic moves instantly from blue to green. If something is wrong, switch back to blue. 5 seconds to roll back. Canary deployment takes a different approach. Deploy the new version to 5% of your servers. 5% of real traffic hits the new version. Monitor error rates and performance. Looks good? Roll out to the remaining 95%. Problems found? Roll back just those 5% servers. The risk of each deployment drops dramatically. You are never betting the entire production system on one release. Every pipeline step runs on an agent, a virtual machine that executes your commands. Microsoft-hosted agents are the easiest option. Azure spins up a fresh VM for every pipeline run. Pre-installed with common tools, .NET, Node.js, Python, Docker, Git. Free tier included. Pay per extra minute. But here is the mistake many teams make. Microsoft-hosted agents start cold, they download dependencies every time. For large projects, this adds 5 to 10 minutes to every build. Self-hosted agents stay warm. Your dependencies are already there. Builds run in seconds instead of minutes. And here is the part that scales across teams. Pipeline templates. Define your standard build and deploy process once in a central YAML file. Every team references that template. When you update the template, all pipelines get the update. Consistent standards across 50 teams without manual coordination. Now pay attention here, this one matters for security. Your pipeline needs credentials to deploy to Azure. The wrong way, put the service principal password directly in the YAML file. That password is now in your repository. Forever. The right way, service connections. You create a secure credential in Azure DevOps once. The pipeline references it by name. The actual credential is never in code, never in logs, never visible to developers. Azure environments take this further. Each environment, dev, staging, production, is tracked in Azure DevOps. You see which version is currently deployed to each one. Every deployment is logged with who triggered it and when. When something breaks in production, you know exactly what changed and when it was deployed. This audit trail is not just useful for debugging. Many compliance frameworks require it. Let me show you the complete pattern used in production Azure deployments. Developer pushes code to the main branch. Pipeline triggers in under 10 seconds. Stage 1, build. 3 to 5 minutes. Restore dependencies, compile, run all tests, publish the artifact. If tests fail, pipeline stops. Nothing moves forward. Stage 2, deploy to dev. 2 minutes. Same artifact goes to the dev environment. Smoke tests run automatically. App health is verified. Stage 3, deploy to staging. Integration tests run against real staging data. Then, the pipeline pauses for approval. The QA lead reviews staging. Clicks approve. Stage 4, production canary. 10% of traffic goes to the new version. Azure Monitor checks error rates and latency for 10 minutes. Everything healthy? Full rollout to production. Problem detected? Automatic rollback. From commit to production, under 30 minutes. 0 manual steps after the initial commit. Full audit trail of every action. This is part 23 of the Azure series. If you are serious about becoming a cloud engineer, subscribe and keep going. Next up, Azure Cosmos DB, the database built for global scale. Let me bring it all together. Azure Pipelines puts your entire deployment process in a YAML file in your repository. It triggers automatically on every commit. The same binary is compiled once and promoted through environments. Build pipelines catch broken code before it reaches any environment. Tests run on every push. Failures block progression. Release pipelines deploy through dev, staging, and production systematically. Environment-specific configuration injected at deploy time. Approval gates give you human control exactly where you need it. Deployment strategies blue, green, and canary eliminate downtime and reduce the risk of every single release. The result? Your team deploys more often, with more confidence, with less risk. Deployments become boring. That is exactly what you want. This is part 23 of the Azure series. Subscribe and keep going. Next up is Azure Cosmos DB.